Hi viewers, welcome to our channel Kavithashok Educational and Motivational channel. Right. Today we are going to discuss an important topic in the permutations combinations. The topic is circular permutations. In the beginning only we discussed something about the circular permutations. What is the difference between the linear and circular permutations? We discussed previous case. So once again we will recall that and we will discuss in detail about the circular permutations. Once look at here now. Suppose we want to arrange A comma B comma C in a circular permutations. So before going to arrange in a circular permutations, if we arrange in a linear permutations, look at here now. A, B, C. We are arranging in a line. So that's why this is a linear permutation. If we arrange the same members in a circle, so A is here, B is here and C is here. So what is the difference between these two? If we know the difference, then the problems will be very easy. Look at here now. In this linear permutation, what is the starting position? Yes, A is the starting position. What is the ending position? Yes, C is the ending position. So in case of a linear permutations, we have the starting position as well as the last position, ending position. What about these in a circular permutations? Which is the starting element? A, B or C? So we can't say that one of the element is the starting position. So in circular permutations, so there is no specified initial position, so then automatically there is no end position also. So that's why we can consider any one of the position as the starting position. Whatever you want you can take. If you take A as the starting position, that will be fixed. Then only these two elements get changed. Either B comma C or C comma B, like that. Is it clear now? So that is the main difference between the linear and the circular permutation. Once again, in case of a circular permutations, we don't have any starting and ending position. So we have to consider any one of the position as starting position. That's why if three elements are there, we can arrange them in three factorial ways. ABC, ACB, BAC, BCA, like that. We already know that one. But in case of the circular permutations, if any one of the position is fixed in the sense here, this will not be participate in the permutation. So only these two can change. So these two can change in two factorial ways. Here 3 factorial we can get, here only 2 factorial we can get. That is the main difference. Is that clear? So if n elements, if you want to arrange, we can arrange in n factorial ways. In case of the circular permutation, if you want to arrange n elements at a time, instead of getting n factorial permutation, simply we can get n minus 1 factorial permutations. What is the difference? Why? Because here one of the position we can consider as the starting position, so that will be fixed. It will not be participate in the circular permutation. So that's why this is fixed in the sense remaining elements can interchange. So in n elements, one element is fixed in the sense we have n minus 1 number of elements. That's why you can get n minus 1 factorial permutations. Okay. Suppose if so on n elements are there. In n elements, if you want to arrange r elements, so this will be NPR. So this is very important case. In case of the linear permutation, if you want to arrange r elements from n dissimilar things, the number of arrangements will be NPR. In case of the circular permutation, if you want to arrange r elements from n dissimilar elements in a circular way, instead of getting NPR, we can get NPR by r number of permutations. This is NPR and this is NPR by r. So once we will check. In case of n factorial, suppose. So what we can get here? R value will becomes n. Means what? From n elements, we are taking all elements. So that R value will becomes here n. So then what we can get here? NPN by this is n. Why? Because R value will be n. So NPN is nothing but n factorial by n. n factorial is nothing but n into n minus 1 factorial by n. Then n get cancelled. Here we can get n minus 1 factorial circular permutations. Is it clear now? So in case of the circular permutations, instead of getting n factorial we can get n minus 1 factorial. So this is the thing. The number of circular permutations of n dissimilar things taken all at a time is n minus 1 factorial. Here nothing is given in the sense clockwise direction and anti-clockwise direction will coincide. If clockwise and anti-clockwise is coincide, instead of getting n minus 1 factorial, simply we can get n minus 1 factorial by 2 permutations. N minus 1 factorial by 2. When specification is given, if one direction is given, instead of getting n minus 1 factorial, we can get n minus 1 factorial by 2. Why? Because in the case of garlands of flowers, chains of beads, there will not be any change in the direction. If garlands of flowers are there, if we cut like this here, okay, from that direction clockwise will becomes here anti-clockwise, from that direction anti-clockwise will becomes the clockwise. So when the clockwise and the anti-clockwise is coincide, then we can get half of the circular permutation will decrease. That's why we can get n minus 1 factorial by 2. So in exams, when we are reading the question, circular permutation is there, that is n minus 1 factorial along with the circular permutation. If garlands of flowers, chains of beads, and specification of direction. Specification of direction is given. Simply instead of taking n minus 1 factorial, we can take n minus 1 factorial by 2. Now we will discuss in detail in the circular permutations. Right. Find the number of ways of arranging 5 boys and 5 girls around a circle. That is our first question. Find the number of ways of arranging 8 persons around a circular table if 2 particular persons were to sit together. Right. Total how many members are there? 5 boys plus 5 girls. Total n is equal to 5 plus 5, 10. 10 students. Right, around a circle. We want to arrange the number of ways of arranging 5 boys and 5 girls around a circle. Right. So whenever we are arranging in a circle, okay, like this here, 3, 4, 5, 6, 7, 8, 9, 10. Whenever we are arranging in a circle, number of circular permutations is equal to, here circular permutation, instead of getting n factorial, we can get here n minus 1 factorial. So that's why because one of the position is fixed. In out of 10 students, one student we consider as the starting position. So that's why that is fixed. So instead of getting n, we can get n minus 1 factorial. So then this is 10 minus 1 factorial. This is equal to 9 factorial. Next. This is our first answer. Next. Find the number of ways of arranging 8 persons. 8 persons in the sense n value will be 8. Circular table if 2 particular persons were sit together. So again we will take a circle. Okay. In that 2 members we can consider as 1 unit here. 2 members we can consider as 1 unit. Why? Because particular persons were sit together. Remaining how many members are there? 6 members. 1, 2, 3, 4, 5, 6. So whenever we consider 2 persons as 1 unit, each person act as 1 unit. Each person act as 1 unit. So total how many units are there? 1, 2, 3, 4, 5, 6, 7. 7 units. We can arrange 7 units in 7 minus 1 factorial way. Why? Because that is circular permutation. First we consider those 2 persons as 1 unit. Then remaining each person act as one unit. So total 7 units. 7 units can be arranged in 7 minus 1 factorial ways. Now again these 2 persons are there. 2 persons. They sit in a row only. Is it clear now? Total may be in the circular permutation, but these 2 persons sit in a row. So 2 persons we can arrange in 2 factorial ways. So by fundamental principle, the number of arrangements is equal to 7 minus 1 factorial into 2 factorial. This is equal to 6 factorial into 2 factorial. Is it clear now? Once again. So whenever circular permutation is there, we can arrange in a circle. 2 persons were sitting together in the sense we can consider the two persons as one unit. One unit in the sense remaining each person act as one unit. Total 7 units are there. 7 units can be arranged in 7 minus 1 factorial ways. Why? Because this is a circular permutation. Now again these 2 persons can be arranged in 2 factorial ways. So by fundamental principle, the first work can be performed in m ways, 7 minus 1 factorial ways. The second work can be performed in n ways, that is 2 factorial ways. Then this will be 6 factorial into 2 factorial ways. So like this we can solve the given problem. So one more important question, 4 marks question. We may expect this question for 2021 annual exam. So listen carefully. Find the number of ways of seating 5 Indians, 4 Americans and 3 Russians at a round table. So that first condition, all Indians sit together. Second condition, no 2 Russians sit together. The third condition, persons of the same nationality sit together. Right. So we will arrange like this here. Total n is equal to first 5 Indians, 4 Americans, 3 Russians. So that's why n is equal to 5, 4, 9, 3, 12. Total 12 members are there. Right. What is the first condition? All Indians sit together. Right. All Indians sit together. Now we will take the round table first. How many Indians are there? 5 Indians. Consider 5 Indians as one unit. Remaining 4 Americans are there. 1, 2, 3, 4. 4 Americans. And 3 Russians are there. 3 Russians. Right. So whenever sit together is there, we can consider that as one unit. So whenever this is one unit, remaining each person act as one unit. How many units are there now? 1, 2, 3, 4, 5, 6, 7, 8. So total 1, 2, 3, 4, 5, 6, 7, 8. 8 units can be arranged in 8 minus 1 factorial ways. Why? Because circular permutations we can arrange in 8 minus 1 factorial ways. Now again 5 Indians can be arranged in 5 factorial ways. So that's why the number of circular permutations will be 8 minus 1 factorial into 5 factorial. So this is equal to 7 factorial into 5 factorial. Once again, all Indians sit together. So sit together is there. We can consider 5 Indians as one unit. So if you consider this as unit in the sense each person act as one unit. So total 4 Americans, 3 Russians. So 7 plus this unit. Total 8 units. 8 units can be arranged in 8 minus 1 factorial ways. Now 5 Indians can be arranged in 5 factorial ways. So the number of circular permutations is equal to 7 factorial into 5 factorial. Next. Second. No 2 Russians sit together. No 2 Russians sit together. Right. We already know. Whenever no 2 condition is there, just leave that. How many members are there? Russians. First leave the Russians. How many members are there? Russians? 3 members. Just leave it. Arrange these 2 persons, 5 Indians and 4 Americans. Right. First take the circular permutation. 5 Indians are there. 1, 2, 3, 4, 5. 4 Americans are there. 1, 2, 3, 4. Three, 2, 5 and 1, 2, 3 and 4. Yes. First arrange other than Russians. So how many ways we can arrange? 1, 2, 3, 4, 5, 6, 7, 8, 9, Total 9 can be arranged in 9 minus 1 factorial ways. Whenever no two Russians are there, just leave that Russians. Remaining persons arrange in a circle. So like this, 9 minus 1 factorial ways we can arrange. Now, for the Russians, how many places are there? Look at here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places are there to sit Russians. If they sit in these places, then automatically the condition will be no two Russians sit together. So, how many ways they can arrange? 2, 3. These are the things. So, total how many places are there? 9 places. In these 9 places, we can arrange 3 Russians in 9p3 ways. Is it clear? First, arrange other than Russians. Other than Russians, how many members are there? 9 members. 9 members in a circular permutation we can arrange in 9 minus 1 factorial ways. After arranging this, how many places are there? 9 places are there, remaining places. In the 9 places, we can arrange 3 Russians in 9p3 ways. So, we can arrange them in 9 minus 1 factorial into 9p3. So, that is equal to 8 factorial into 9p3. Now, last question. Persons of the same nationality sit together. Third condition. Same circular permutations. Same nationality sit together. Again, together is in 5 Indians we can consider in 1 unit. Next, 4 Americans we can consider as 1 unit. And 3 Russians we can consider as 1 unit. Now, how many units are there? 3 units are there. 3 units can be arranged in 3 minus 1 factorial ways. Now, 5 Indians can be arranged in 5 factorial. 4 Americans can be arranged in 4 factorial. 3 Russians can be arranged in 3 factorial. The total number of arrangements will be 3 minus 1 factorial into 5 factorial, 4 factorial and 3 factorial. So, finally, this is 2 factorial into 5 factorial into 4 factorial into 3 factorial. Once again, first consider 5 Indians as 1 unit, 3 Russians as 1 unit, 4 Americans as 1 unit. Why? Because all sit together is there, persons of the same nationality. So, for the same nationality, we have considered as 1 unit. So, total 3 units are there. 3 units can be arranged in 3 minus 1 factorial ways. Why? Because that is a circular permutations. Now, 5 Indians individually they can arrange in themselves in 5 factorial ways, 4 Americans 4 factorial ways, 3 Russians in 3 factorial ways. The total arrangements will be 2 factorial into 5 factorial into 4 factorial into 3 factorial. Okay. In the next class, we can discuss more about the circular permutations. Okay. Thank you. Thank you very much.